Right, so who we have next is Claire Houston, and she's talking about AI in production. So this is going to be a really interesting talk, I think. So over to Claire.
Hi, thanks so much for the introduction. So as we said, I'm going to be talking to you guys today about build versus buy AI in production. So considering when you should want to buy and pay for your machine learning services, or when you should actually start from scratch and build your own. But first things first, I want to introduce to you guys to my friend Sally. So Sally owns a coffee shop. She has a pretty successful website, but she wants to take it to the next level. She wants to take it that step further. So she's thinking, and bingo. She has the perfect idea that she knows is going to take off and do great for her website. So next thing, she wants to get it out into the world and make sure that she's reaching as many people, as many customers as successfully as she can. So she introduces a chatbot and has a stranger come and chat to the chatbot. So the idea is that they will speak to it as if they were speaking to Sally herself, have a very natural conversation using speech that will then the chatbot will then feed the information into our website, into the great new product, and then have the information fed back out. So Sally's a pretty good idea of how she should do that. She should do it using machine learning. But the question is, Sally's wondering, does she need to go and get a master's in deep learning? Does she need to know everything there is to know about neural networks before she gets started? Or is there a more straightforward route? Could she go and pay for a machine learning service that would actually be able to provide a lot of these services for her? Can she go down that route? When should she go down that route? So that's what I'm looking to cover today. Whether you're deciding that if you ever want to touch machine learning, you have to start from scratch and build everything from the ground up, and everything has to be the best, most specific model to your exact problem. Or if you're in the opposite camp, if you're thinking that to do anything to do with machine learning, you're going to have to do all that and you just want to avoid it. You're a developer through and through, or you're just starting out. Well, this is the talk to show you how you can get started in using AI in production. So today we're going to cover the difference between the two. You're going to learn how to know when to use one, when to use the other. We're going to cover some of the offerings from Azure Machine Learning, whether that's the machine learning services they have on offer, or learning how to build your own model on their platform. And finally, we're going to look at some machine learning coding examples. So, as was said, my name is Claire Houston, and I'm a senior AI engineer at Kainos. I've been working in AI for about the last 3 years or so, working in the AI practice in Kainos for the past 2. And I work in natural language processing, so processing a lot of text documents with machine learning. I've done a lot of work with chatbots, and I've done work with productionization. And something that I think is important to remember when it comes to productionization, it isn't always that we've built a very specific model, got that up and running either by us or the customer's given us. Frequently, it is about using a machine learning service that is out there already, that we change, that we alter, that we implement into existing systems, and then put that into production. And that frequently is exactly what the customer wants, and they get to the value so much quicker. So I think that's important to keep in mind whenever you're watching this presentation. So what does it mean to build a model, and what do I mean whenever I say a machine learning service? Because I've said that word a lot. Well, whenever I'm talking about building your own model, I'm saying whenever you have to gather all the data yourself, you process it in some way, and then you train your algorithm and to make a machine learning model. But you know you can't just do that once. You have to gather a bunch of machine learning models and train. There's a reason there's a circle going round and round and round. It takes a wee bit of time. Then whenever you're happy with your model, you have to deploy it. That'll take some setup, and you have to figure out the best way to do it. Finally, you have to make sure that you're continuing to monitor and manage your model to make sure that it remains providing use and value to your customers. As if you don't keep up, the model could quite quickly come out of date. For instance, if we're talking about Sally in her coffee shop, what happens if they're talking about this brand new coffee that's come out, or this brand new thing from Starbucks, like a macchiato or a macchi latte frappuccino? That needs to then be taken into consideration whenever you're talking about your model. So what are some of the features that you want to consider whenever you're talking about building your own model? Well, you need to think about the skills. You need the skills of a data scientist, an ops engineer, and a software engineer. Specifically, you need those data science skills to be able to prepare your data. You need your ops engineer skills to actually be able to deploy the model that your data science has prepared the data for, built the model for, then get deployed. And finally, you need the software engineering skills to actually be able to call to your model and be able to implement it into your existing system. As your model sitting on somebody's laptop, or for that matter, sitting on the cloud, isn't very useful by itself. It needs to be integrated. Something that's important to consider whenever we're talking about machine learning is cost. For instance, you need to pay for the cost of hosting the data. You definitely need to pay for the cost of training the data, training the model, unless you want to sit with your laptop for about 8 hours training it and only to find that the model is pretty much useless when you get to the end. Totally hasn't happened to me far too many times. So you want to train in the right size compute. And then finally, you need to pay to deploy your model to make sure that whether you want it to be always available, allowing your customers to always access it, or if you're happy to do batch processing. That all adds up. All of that is on you to manage whenever it's your model. Data gathering is required whenever it comes to building your own model, as you need to feed in the data. That is what your model is made of. And it's important to remember that it has to be of a good value. It has to be, say if you're doing supervised learning, so that you give it data and you want it to pick a specific label, all of the data that you're feeding in needs to be labeled. It can't just be raw. Flexibility whenever you're building your own model is very high, which is great because you're building it for your specific purposes, so it's always going to be able to do what you want it to do, provided all the other caveats are fulfilled, of course. But it does mean that it is very specific to you and your needs. Model maintenance, which I touched on before, is of course required. You need to always make sure it remains up to date with your customers and it remains useful to them. So let's look at the other side of the spectrum, machine learning services. So these are pre-trained models that exist up in the cloud that the likes of Microsoft or AWS have designed, built, and are sitting there ready to go. They cover services such as language translation, translating speech to text, text to speech, vision custom classification, image classification, and many more things beyond. But it isn't an infinite list. The models have to exist up there. And they're very easy to access. You only need developer skills to do so, seeing as it's a simple API call to be able to implement it into your system. And we'll see some of these later on. So what are the features you need to consider whenever you're thinking about buying an ML service? Well, as I mentioned, the list of required skill set has gone down from 3 to 1. You simply need to be able to make that API call to actually implement it into your system, and a few bits of authentication. That's quite a straightforward process. The cost is an interesting one, as it will entirely depend on the machine learning service that you actually use. So are you asking it to translate a simple sentence into a different language? Realistically, that isn't going to be too dear, but if you're trying to stream a video of and requiring image classification the whole way through, that is going to rack up costs quite quickly. So make sure to check those out before you invest too heavily in those services. Data gathering as a feature isn't required, seeing as these are pre-trained models, so they're already up there. All you have to do is feed it the data that you want to be classified or examined or information extracted from. Flexibility is low in comparison to building your own models, seeing as there is a finite number of services. That number is growing, but frequently they're trying to suit a maximum audience. They aren't trying to figure out your exact needs for your very niche problem. Important to remember. And finally, model maintenance isn't required in the sense that you aren't responsible for the model and you don't have to continuously feed it new information. But on the other hand, it does mean because you're not responsible for the model that you actually have to make sure that if it suddenly stops doing what your customers want, oops, you have to maybe write a very nice email to the likes of Microsoft asking them to fix it. So there are 3 important questions that I always ask myself whenever I have a new problem that I know can be solved with machine learning. And I want to differentiate between should I build my own model or should I go and pay for a service? They are, is it a solved problem? Do I have access to the data? And will I get good results? So first things first, is there a solution already out there that I could pay for and immediately get value from? If that's the case, it's a no-brainer. Pay for it. Don't start and try and come up with your own invention. trust me, you're a good few years behind an existing service. It's already been done. That's only going to get better, and you're only going to be playing catch up. Never mind the amount of time, effort, and money you'd have to pour into it trying to get it up and running. You're on Google. It makes much more sense to actually pay for that service and get running with the thing that you wanted to do, the outcome that you want to have overall. Secondly, do you have access to the data? And I don't mean do you have access to a lot of data that's just kind of sitting there in a kind of useless fashion. Do you have the data that you need to solve your problem? Can you sort it into a nice fashion? If not, it's going to require some more processing before you're able to actually think about machine learning. With no data, you don't have a model. Finally, will I get good results? Now, I know this sounds a bit like I'm putting the cart before the horse, but bear with. Essentially, what I mean by that is there's a lot of time and effort that will go into if you're actually building a large-scale machine learning model, and it's important to do an initial check first of all. Do a proof of concept or a very small MVP to actually test will it work. Do you have the data you think you do? Will you be able to siphon it in? Will you be able to upscale to the model that is required for this purpose? All of which will save you a lot of heartache further down the road. So now we know the difference between buying and building. Let's look at some of the ways that we can do this. First things first, picking a platform. Now today I'm going to have a look at Azure, but it's important to remember that there are a number of different options out there. I sort of like to think of there being the big three. There's Google Cloud, AWS, and Azure. All of these have machine learning offerings that are able to do quite similar things to varying degrees of accuracy. They're all very good, to be perfectly honest, but one may be slightly better than the other. But that isn't the be-all and end-all whenever it comes to the service. One may provide more for a similar cost, and one you might already have lots and lots of stuff on that infrastructure. If every single other thing in your infrastructure is AWS, can't say I'd recommend going to Azure for that one tiny service. Stick with the one that makes the most sense for you. So as mentioned, today I'm going to be giving you coding examples using Azure. And for that you will need an Azure account and Azure subscription. Although a lot of the examples that I'm giving, particularly with machine learning services, they actually have a free tier associated with them, so you can actually sign up and you won't have to pay anything for them, which is pretty handy. Secondly, the examples that I'm showing are all written in Python, as that's the language it's my favorite language. But not all of the examples have to use Python. For example, the machine learning services, Node.js and C# are frequently options. So don't let that put you off actually getting started with machine learning. There is flexibility when it comes to machine learning, when it comes to the programming languages. So let's get started. Let's jump back to Sally and her problem. Her solution for connecting her chatbot and getting that up and running. So first things first, she wants her customers to be able to speak to her chatbot and have a conversation with it. That means that the input speech has to be decoded into text. Speech recognition has to be performed. So what does that look like? Well, the incoming sentence needs to be said, hello. That will be converted into the wavelength that we see and is stored. That then gets processed by the computer into individual numbers, as a wavelength just won't understand that. Numbers, on the other hand, great. This set of numbers then gets processed by a neural network and then matched up to an existing word in a database. Now you might be wondering why machine learning has to get involved. It's individual numbers and it seems like a pretty straightforward matching process. But I'd ask for you all to cast your minds back to whenever Google Assistant and Siri first came out. The number of times I said hello Google to a blank screen that just blatantly ignored me was not funny. Suffice to say that whenever there's a lot of different ways that different people, different genders, different accents, different whatever, can say hello. Hell, there's even different ways that we can say hello. About you. So it's important to remember that it isn't just a straightforward matching process. And that's wherever machine learning comes in and makes that process a lot more accurate. But all that's to say, Sally's wondering, should she build her own machine learning model to perform speech recognition? Well, is it a solved problem? As I've touched on, while they can be annoying, Alexa and Google Home do exist, so there is already solutions out there. Does she have access to the data? Well, she doesn't have lots and lots of speech recordings that she has translated for, so no. And will she be able to get good results? As was mentioned, it took a long time for Google and the like to actually be able to figure out accents, so it's going to take a similarly long time for her to get good results and a very large neural network required. So in this case, the best recommendation for Sally would be to buy. Here's an example of Azure speech-to-text recognition.
Hi, I would like to buy a moderately expensive coffee from Ethiopia. I want enough to last me a month, and I drink 2-3 cups a day.
So I hope you guys heard that. And essentially is just an example of whenever you speak and the transcription being performed. You can see it was pretty accurate, maybe a couple of commas missed, but that was about the height of it. Overall, a pretty good service. So to actually do that, there were 4 key pieces of code implemented. The first, not necessarily code, but you had to create the resource on Azure, so following the speech. Next, you had to import the speech SDK after having installed it on your laptop. Then you set the configuration object and the actual speech recognition object using the configuration. So this is essentially the key to the speech and the region that you want to perform this operation in. And then finally, you call the recognition. Pretty simple process. Next up, we have natural language processing. So we have the input text, but we want to extract insight from it. We want to figure out what are the key words mentioned, what are the key phrases, what is the overall goal of what the person's trying to say. The computer isn't going to understand that right off the bat. This is where natural language processing come in. It is the avenue, it is kind of the department of converting human speak into understanding that computers can do. And it'll essentially break down your text into words, into meaning, into individual entities, and so on. That means that we can actually extract that information and perform an action on it in some way. Some task can then get performed. So if I say, hi, I would like to buy a moderately expensive cup of coffee from Ethiopia. I want enough to last me 1 month, and I drink 2 to 3 cups a day. You have immediately figured out that I'm talking about coffee. I don't want to pay too much of it. I want it from a specific country. I drink 2 to 3 cups a day over the period of a month. All of that is instantaneous to you. But for a computer, that has to go through a certain amount of processing to pull out the required information. And that process is usually done through machine learning. So Sally is wondering, should she spend the time and dedication to actually building her own machine learning model to perform that action? Well, is there existing solutions available? The answer is yes. There's a lot of ones that are available for free, such as Spacey or NLTK, or there are offerings that you can actually pay for from the likes of Azure or AWS. So solve problem. Does she have the data to do it? Well, although Sally does have lots and lots of examples of customers coming with her for coffee queries, it isn't actually labeled. It's not, each of these isn't broken down into this word means coffee, this word means this word means this, and so on. So while she has the data in a raw format, it isn't labeled and therefore it isn't useful, so it would have to be processed. And finally, as you can tell, there was a few different things pulled out on the screen back there, such as language, key entities, and so on. Each of these requires a different machine learning model to actually be built for that specific purpose. Frequently, Sally may not need that information, but if she was building her own machine learning model, it would be up to her to maintain that and ensure its accuracy. So multiple models would need to be maintained, and that's an effort. So in conclusion, should you build your own natural language processing? Answer is probably better to buy it. So you can see here an example of Azure Text Analytics. And you can see a lot of text being going on the screen, but it's actually quite a simple process. Each of these is just individual method calls to perform a slightly different piece of text analytics. So you can see here it running. And the important information is extracted from it. So it knows about coffee, Ethiopia, and it actually provides Wikipedia links, for example. It knows that the language I'm speaking in is English, and it's pulled out other metrics as well. So, pretty useful. And you see here, the key pieces of code are the resource that you have to generate, the text analytics, the relevant importation, the authentication that you have to perform to say, yes, I'm happy for you to actually use this resource on Azure, and the different methods that need to be called. All of these are from the one resource, which is pretty handy. Next, we have speech synthesis. So we want it to be a one-to-one conversation. We can't have the customer just talking to the chatbot. it needs to be able to chat back. And this is performed using text-to-voice or speech synthesis. So what does that process look like? Well, there's two key pieces of machine learning here. The first is whenever it's converting the written text into words that will actually be spoken. So if I say year 1843, doesn't sound quite right, does it? I know whenever I'm reading that text aloud that it's actually the year 1843, and there can be a number of cases of this. So there needs to be some processing to ensure it's being processed in the correct way. Next, it's converted into phonemes, which is essentially how words are pronounced phonetically. If you ever look up the definition of the word on Google, as I'm sure you've done like me to figure out how to spell things, you will see underneath random letters, and those are actually tell you how to pronounce that word. There's a bunch of people who can read it, and those are called phonemes. Then they're converted into sound, and the audio is played back. So that lastly being an example of machine learning. So Sally's wondering, should she build her own machine learning model for speech synthesis? Well, is it a solved problem? Jumping back to Alexa and Google Home, we know that it is. Does she have access to the data? Doesn't happen to have lots and lots of voice recordings lying around, so the answer is no. And finally, will she get good results? Well, like with the speech recordings, there have been lots and lots of work done to make the voice sound less robotic and less uncanny valley. So no, she probably will not get a good result without having a very large-scale model. So in conclusion, she should probably buy. And here is an example of text-to-speech.
I'd recommend the southern weather if I'm honest. Getting at least 3 bags. It's a good all-rounder and should please everyone.
So you can see there, it's not the most natural sounding voice, but it's not too shabby for a very quick setup. So you can see there that you actually use the same speech resource that you created before. You import the exact same speech SDK, you set up the same configuration, but instead of creating a speech recognizer, you create a speech synthesizer, and then call it on the text that you wish to be spoken. For each of these examples that I've given previously, you can see that they are each very generic examples that a lot of people can find a lot of use cases for. And there are great reasons why you should buy and pay for those machine learning services. And hopefully, you can see through the coding examples that they're very easy to get started with. But let's look at something a bit different now. Sally is delighted. We've set her up with a brilliant chatbot that allows everybody to speak and talk to her process and get access to her brilliant new product that she came up with at the start of the presentation. But you may be wondering what that is. Well, it is a coffee selector. Sally wants each of her customers to speak to the chatbot and get a great recommendation back, just as they would if they were speaking to her. And to do this, she wants machine learning to provide the solution based on the data that she has been gathering for the past number of years. So if we consider the questions, is it a solved problem? Well, no. Nobody out there is doing this exact same thing as her, that she offers her perfect coffee recommendations. Does she have access to the data? Well, yes. She has been making these recommendations for years, and she has countless emails where customers gave her exact information and she made a recommendation back. Finally, will she get good results? Well, from the initial prototype that she's designed, things look pretty promising. She's checked a few of the resources, and so far, things look good. In this case, only one next step makes sense. It's time to build. So you may remember this diagram from the start, and it is Azure ML Studio, and essentially, which is Azure's platform to allow you to deploy your own built from scratch machine learning models. They allow you to store the data that you've prepared online in a safe place. You can then build and train your model either locally using their infrastructure, run it from your laptop onto the cloud, or run it entirely in notebooks on their hosted compute, whatever you want. So then you'll be able to train that on hosted compute of the right size and be able to speed things up or take longer if needs be. You'll then train. You'll be able to register and manage your models, so essentially compare them to figure out which is the best for your solution and actually keep aware of that, something that can be quite tricky if everything's on your laptop. Then you build the image to allow you to deploy it, so installing all the installations you need, packaging it up. and then you'll be able to deploy it. So you'll be able to deploy it in the fashion that you need, you'll be able to monitor it and make sure that it remains accurate for your customers overall. This process will take place again and again and again, and you do all of it on Azure. So here is an example of running an experiment. So as you can tell, this is off my laptop using Visual Studio Code, and I have set up just an example of the train and model Python files that I then run from my experiment script. Whenever I run this, it will then actually deploy onto my existing portal, and I'll be able to actually compare it against some of the previous experiments we've seen. So as you can see, I'm running it. And then almost immediately, it is actually running online. And you can see the comparison between the previous ones, whether that's how long they've run, the loss, the number of epochs they've run, whatever information you want to display, you can actually run it via the portal. And there's a couple of key pieces of code for doing this. You'll set up the temp workspace, so the actual machine learning workspace, the relevant imports, get them in. You'll actually be able to set up the workspace and all the installations. So that is for example, the experiment, the environment that you need to set up. You can specify all that. That'll then run on the hosted cloud Azure instance, the compute instance, and then you'll be able to run. It's all a pretty straightforward process. I'm not going to go into any detail around how to deploy it, as that could probably be a talk in its own right, but I encourage you, if you're interested in machine learning, specifically building your own models, to check out deploying them via this kind of example. So, brilliant, we did it. Sally has got her system. She has been able to create a chatbot that can speak to the user in natural text. They speak, the text gets the speech gets translated into text, and then the information gets extracted from it, passed to a machine learning service that's bespoke and will recommend the perfect coffee for them. This is then synthesized out, and it's complete. They'll be able to have a brilliant chat. So what are the key takeaways that I want you guys to take from this talk? Well, I want you to remember that no one shoe fits all. You can't just build every single model. You'll waste time, effort, and honestly tears trying to do it that way. But you also shouldn't buy every resource either. There isn't specific enough resources out there, and it's important to be able to identify when you should buy and when you should build. You don't need to be a data scientist to start using machine learning in your software. You can simply be a software engineer to make those relevant API calls and get your products kickstarted with machine learning, and bring them in to make sure that you're making the most of these brilliant resources that are already out there. And finally, I want you to remember the 3 questions that I always say. Is it a solved problem? Do you have access to the data? And will it work? If you remember those 3 when you're trying to decide, should you build or should you buy, you'll be in great shape. So today we covered the difference between building and buying for machine learning, how to know when to build, when to buy, the Azure machine learning offerings we have, and that are available to everyone for both building your own and buying, and some machine learning coding examples. Thank you all so much for listening, and that is my Twitter and LinkedIn if you're interested in reaching me on either of those. Thanks very much.
What a fantastic talk. It's always good to hear what's going on in the world of AI and machine learning. And of course, we're going to go into a little Q&A session with Claire. She's going to kindly answer a few questions based on her talk. So here we go.
Okay.
Thanks. That was brilliant.
Thanks.
Really enjoyed that.
That's good. I don't know if everybody could hear, but like at the very end, there's just an incredibly small yappy dog outside. That was slightly concerning.
You'd be amazed at some of the noises we've been getting.
It's amazing. It's like it's honestly, I'm just happy to be out of the house. Like nice hearing people and hearing random dogs again. It's great.
I know. I think somebody mentioned that there's a lot of dogs around in this area for some reason. They're kind of a variety of them. But yes, so we've been getting some questions coming in. I'm just going to run through them very quickly with you.
Sure.
So, yeah. So you talked about data and how you need a wide variety and training your models as well. What have been the major challenges you've experienced in training your models?
So honestly, it can be a case where you think you have access to the data, and that's why I have the actually do a prototype, because you can think you have access to the data, and then when you actually feed in, you realize that it maybe doesn't cover all examples. You can come up with a model that's quite biased. If it has lots and lots of one class of examples, so lots of positives or lots of negatives, and you only got a little bit of the other, it can unbalance your model. And so basically just making sure that you have the data that will actually do the job, and making sure it's classified in an appropriate way and labelled, instead of it just being sitting there randomly, which is still useful. You can still do analytics on it, but maybe it's not the right time for machine learning yet.
No, absolutely. Do you normally find that's quite a difficult process to get good quality data? Or?
It can be. It's sort of different people are different places when it comes to machine learning. As I was saying, you need data to have a model. But you can actually then set up people to start being able to scrape it, get it in the right place. So if we're given enough time, it can be grand. You can get it to that right place. Other times you can't, but it's something that I definitely encourage everyone, if they're considering getting into machine learning, to check that they actually have the data that they think they have, and that it's in a good enough format to get started.
That's fantastic. Yeah, and I mean, data is what the world is driven on these days, absolutely.
100%.
Yeah, and just where you were talking about the early days of Google and, Siri and so on, of course, accents were a big blocker, and especially Northern Irish one and Scottish.
I really wasn't joking when I said it was the most annoying thing, because I had just got a new phone and turned on Google Assistant on it. I was so excited to start using it, and then I was talking to it and it just wouldn't work. And then my boyfriend at the time was like, "Okay, Google," and then bingo, worked straight away. And it was my phone, and it was just from that point I was like, "Okay, that's done for a while." Took a couple of years to earn my trust back from there.
That's fantastic. Do you think that's now changed, or is there a lot of work?
I think we're seeing different problems. So those have been addressed, but we're seeing different ones come up. Like, for instance, I'm not sure, I have a feeling many people from here might be on Twitter at the minute, if you saw the spotlight issue for the images. So essentially, Twitter did this thing. So basically, it's a different problem where they did this thing where they had an image and they automatically cropped it. So if you're on mobile, what the most interesting place would get shown. And for a lot of those examples, it was if there was a black and white person in the photo, it would focus on the white person consistently.
Awkward.
Didn't mind where you put it. And there were other examples as well. There were some interesting crops and stuff, but it's another example of making sure that you are accounting for all kinds of problems that you can face, and making sure you have a wide range of people in the room helping to identify those problems. Because nobody writes an algorithm hoping it will be biased, but it's just a question to make sure you have enough kind of voices in the room to make sure you're getting enough input on it.
Yeah, absolutely. I mean, you've had some very, very public examples of where it's gone wrong, where they've pulled that training out to the public and it's gone wrong. Do you think in future that's something that can still be done? Can we trust human beings to help train?
I think so. I'd like to think so. It might be maybe more in a more controlled way. Maybe there should be more fail checks in there to make sure that what's being fed into it is appropriate. As there are plenty of exploitative features in processing. Maybe there just has to be a screening. Like if you're teaching a child, you don't generally say all of that stuff to it. So maybe you should treat machines with a bit more of make sure what's getting processed. I'm not saying to treat them like kids by any means, but just make sure that whatever you're feeding into it is going to get parroted back out at you. So maybe do some kind of checking around that.
Yeah, just maybe not let it out in the wild quite yet.
Yep.
Where do you see the future going for this technology? What excites you most about what it can do?
Honestly, for me, I'm most excited in putting machine learning in more people's hands. So that's why I would build machine learning models a lot, but I really do use the services, and they can be accessed by people who have no machine learning background and just get up and running. And I think I'm really looking forward to seeing the next kind of generations of applications that just have machine learning embedded automatically and really leverage these services. There's going to be more machine learning models made available that are pre-trained that people can just grab and run with. I think it will be so interesting to see where that goes.
That sounds fantastic. I mean, at the end of the day, I suppose, with the topic of your talk, do you ever envisage a world where there's still going to be services that you will always have to buy or you will always have to build?
I think so. I think because there will just be niche problems, and it might be a case of you use pre-trained models more and more and more, because you'd be surprised how much overlap there is between maybe text and maybe images in the core functionality of the models. But I think we'll always need a bit of skill to actually be able to turn it into something.
Yeah.
And secondly, I think maybe that will change, but then we'll need developers for something else and something else and something else.
Yeah.
As the kind of foundation grows and what's kind of the basis there, we'll always come up with something cool that we need to do on top of it and something interesting. I don't think we're going to, for a while, have machines that can write programming for us. So I think we're always going to come up with a kind of next thing, unless we have machines that are sentient, but that's a whole different issue.
Yeah, well, at least we're not out of a job yet.
Yeah, exactly.
And speaking of the future, if someone were to get started, where would they go? Where would they
So
lead?
if they are getting started from scratch, I would recommend either there's a hands-on machine learning textbook. If you Google that, hands-on machine learning with TensorFlow, it is a great from start taking you through those. If you want a free course, Google do a machine learning crash course that's available. It's kind of gets into neural networks a good bit, but it'll give you the written ones give you a good overview. And if you're a programmer looking to get started, I would really recommend checking out Fast AI, because it's one of those resources that was just like, why did I not look at this sooner? It just gets you up and running really quick. You get something working straight away, which whenever you're doing machine learning, sometimes the most soul destroying thing can be just a model that doesn't work so much of the time. So I'd recommend checking out those resources.
Oh, that's fantastic. Those are some really good tips. And then another question here: how do you do automated testing on these models when they're learning? So that goes back to that piece about not letting it out in the wild, I suppose.
So if you're doing automated testing, whenever you're training it, you sort of have the test in there that essentially just checks how accurate it's been, and that'll be done whenever you'll sort of keep some of the data back and you'll test it through that, and you can do that on the deployed scripts whenever you're doing that. Whenever you're monitoring, whenever you've got it deployed and it's in the wild, you essentially will need to keep back some of the results that it's giving, and you'll need to have a human or somebody like that to actually check those results. Maybe you just fact check them against previous examples that are correct, and so on. So basically, you just want to have some kind of monitoring service there.
That's fantastic. And then, suppose a little bit about what you're working on at the moment as well. Anything fun coming up?
Well, I currently have chatbots in the brain, so was doing a project for a hospital there and creating a chatbot for them and getting just essentially question and answers. They were getting the same questions over and over and over again, and just getting a kind of quick solution up and running for them. I've written one blog on Medium about how to deploy the chatbot, because Azure have great tutorials out there. A lot of the examples I showed today are the tutorials. But when there's a couple of pitfalls you can fall into, so essentially follow this, you'll get up and running, and I'm planning to release one soon about unit testing those chatbots, as this is done through Azure bot framework, and it's the great example for machine learning. Every time I look at the framework and then a year later look away and come back totally different. Unit testing is one of those examples, but it's honestly kind of relevant for machine learning. They keep changing, they keep getting better and better, and it's all great, but it does mean you do have to keep relearning how to use those. So I'll be covering off how to test those, which is great new functionality.
Fantastic. I suppose chatbots sometimes end up with a bad reputation.
Yes.
So how do you counteract that? How do you make it human?
See, that's the interesting bit of whenever it comes to having a chatbot, unless you're willing to pour so much time, so much effort into it, it isn't going to be just as human as you'd like. So it makes sense to have something instead that kind of works. So sort of if you simplify the process a good bit and leverage those machine learning services. So for example, with questions, there's something called Q&A Maker that essentially allows the matched up of the questions. They think of everything that it could want, and if not, then they point it out a human. They give contact here, provide this information. So essentially, it's not so much making it human, but to stop it being frustrating, limit what it can do to make it really, really good at that, and build up from there. pour the time and effort into making sure it's working correctly.
That sounds perfect. Hopefully that will reduce some of the frustrations.
I know. It's just, can it work? Can it give me the answer,
Yeah.
please?
I suppose there's nothing wrong with ambition, but sometimes
Exactly.
they get ahead of themselves, you know. And is there anything in particular that you've been really excited over that's come out in recent year, you know, any developments?
It was, trying to think, I think it was OpenAI. Exciting might be the wrong word, but the free text that they're able to write that they then refused to release because they said it could be used for bad so easily.
Oh, yes.
And then equally deep fakes, like those things are getting crazy, like the amount of
Terrifying.
things that are out there. But so it's sort of exciting to see that technology is there and working. And I'm also very excited to see what are the ways that we're going to be able to combat it and to make sure that we are getting the truth for journalism and the truth for deepfakes out there.
Absolutely. Like with a lot of tech, you've got issues around morality of how tech is used. So that would be a very good, interesting area to look at, and especially mention video fakes.
I know it's something that I'm just really, I think at least part of the reason why I'm so drawn to AI is has so much potential for good in so many healthcare, like how many things to do with COVID-19 have we seen that have been like AI analytics related, but also has the potential to do kind of so much like bad nearly, but without any intention behind it, or even then what happens when there is a malicious intent. And I can just see this becoming more and more relevant. It's one of the reasons I'm so interested in AI.
No, absolutely. Well, that was absolutely fantastic. So, I mean, that's been really good chat, and really
No,
enjoyed
definitely.
that.
It's been
Thank
great
you.
having the questions. Absolutely. Thanks so much for having this. Has been really, really good today.
Yeah,
Really
no,
enjoyed it.
Thank you. It's definitely something different.
No,
You
it
know,
is. It's
and,
class.
hopefully, I think you mentioned you got to see some of the conference as well.
Yes,
and-
no, I did. I
yeah.
really enjoyed some of the talks, the becoming a senior, and then Phil's talk. I caught the majority of it before I had to get in the car and drive here, so I'll have to check it out on YouTube after.
No,
But no, I'm
absolutely.
looking. Oh, and Lauren Taylor's talk earlier today, that was hilarious. Whenever she started playing Smash Mouth at the end, I just giggled. It was brilliant.
I know, obviously, we got a little sneak peek of her talk, so we were just like, that's going to be fantastic.
That is one of those days that you wish you were in the room with everyone to just see, like, just stare at the audience and see how they're going to react.
Oh, absolutely. Because then you also have, I think, a couple of other music related
Yes.
ones. I think Daniel and Neil's as well. So it seems to be more music centric today than we originally intended. But
Perfect.
yes, thank you for coming in,
No,
having a
thanks so
chat,
much.
and for your talk as well. It's really good.
Brilliant. Enjoyed it so much. Thanks.
Absolutely. So.